Hello, my name is Mr. Harper. This is my website, harpersclass.org. We will be using this website in sessions that I teach. So, I am a resource teacher, and I went to our local college and I got a book for pre-algebra, and I would like to do some of these videos so I can help people get caught up before you go in and you take the college placement test and get put way back in a class because maybe you didn't get the math that you needed when you were a kid or when you were in high school, or maybe you just took time off. I had college professors who said, I can't remember any math because when I got out of high school, I didn't need to take any math. Well, that isn't good for your math skills. But you know what? It happens. I am very pro calculator. So, on the parts where you can use a calculator, I might go over using the calculator. I might go over how to do it, but you know what? I don't mind if you use a calculator because when you get into college, they require a calculator. They don't just require a little Dollar Tree store scientific calculator. They require that you buy at least $100 calculator. When my brother was in college back in the early 80s, he had to buy a calculator that was a computer made by HP. So, I have nothing against using a calculator, particularly if you have issues with math. So, this is called a pre-algebra book in college. It's a huge book. And what I am going to do with you guys is I am going to go over each section of this. And I will be putting onto my website, harpersclass.org. I will be putting um, activities that I get from, say, Common Core Sheets, which is a great website for math. I know it's got the name Common Core in it, but don't be scared off by that. It has a lot of traditional math on it, and it's got math that will be going over what we're studying, um, which is pretty traditional. Um, you I will also be including some stuff you can write down, take notes. I encourage you to take notes while we're doing this. So let's get started with chapter 1 is over whole numbers, which is the basis of math. So, right here on the introductory page, I will put a link on in the comments section on what book I am using. I don't know that the college is using it anymore, but maybe you can look up materials on it. But part of this has already been written on, um, just because I don't want to bring up another copy of it right now. I did this with a couple of kids I tutor. So, number 1 just says, name the number of stars shown. Well, there's 8 of them if you count them. Okay, that's a whole number, 8. Write the numbers from 1 to 10. So you just write the numbers from 1 to 10. Here it's matching the number with with the spelled word. And you know what? Some people have trouble with that. And that is nothing to be ashamed of. You know, I sometimes have trouble with my spelling. Okay. Number 4, American flag contains the color green. Or how many American flags um, contain the color green? Well, the American flag would be 0, but I know the state of Washington has pretty much an all green flag. We actually watched a video today in my summer school class on um, the state of Washington. And it's got a picture of George in the middle, but because it's the evergreen state, it's green. Anyway, that doesn't matter much, but the number of states in the United States as a what is it? As a word, not a number. So it would be 50. And you do have to write out numbers at times. And I realize this might be very basic for some of you. And as we go on into the chapters, it'll get much more advanced. But this is designed to get you into it. And there's a lot of stuff in here, even in these sections, that I really haven't thought about or haven't thought about in 20 years and I had forgotten about. So, the first one, Objective A. The objectives were right here. Objective A is to identify the order relation between two numbers. Okay, so to identify the order relation between two numbers, a little bit bigger, easier for me to read. So we're going to start off with the natural numbers are 1, 2, 3, 4, 5, and goes on to infinity. Numbers will just keep getting larger. So the three dots mean that the line continues and the numbers just keep getting larger. Um, so, what I like to think about natural numbers is they're numbers that occur in nature. So that's why you have one of something. Now you could have zero of something, but is that really natural? There were some. I think the Mayans or the Aztecs didn't even have a number for zero. So now whole numbers do contain zero. Because you can have zero of something as a whole number. Whole numbers will not contain negatives because a negative is an integer. And we will be getting into those, but those will be in some chapters in the future. So now right here we have a number line. Starts at 0, goes all the way to 14, and it still has an arrow going. That means the number line just keeps going. So the graph of a whole number is shown by placing a heavy dot on the number line directly above the number. So you can see right here, I have 6. So that was what it told me, was graph the number 6. Now, if I said, well, graph the number 6 and then count 3 above it. So you would go over 1, 2, 3, and you would be at 9. So 6 plus 3 is 9. So a number that appears to the right of a given number is greater than. Now, I want to stress this symbol right here means greater than. Now, the main thing you're going to see this symbol, you're going to want to remember this is when you're doing, say, computer coding, um, computer programming. This symbol greater than might be used. It says if you say x is greater than 3, you're not going to just want to say, well, what's the bigger number? Well, it's going to say x is greater than 3. I had trouble with that because I learned a lot of this stuff in probably the first grade. I remember going over inequalities. I wasn't in a high class, but the teacher said the alligator's mouth always eats the bigger number. I never learned this as greater than. I just learned it as crocodile's mouth eats the bigger number. So it took me a while when I got into computer program to realize, oh, that's what that means. Greater than. So 8 is to the right of 3. So we go over here and we find 8. 8 is over here to the right, and 3 is to the um, left. So you have 8 is greater than 3 because the number to the right is going to be greater. Now, in the same thing, you can also say 3 is less than. Remember, this symbol means less than. All it means is this number here is less than this number here. So 3 is less than 8. Now, I'm going over a lot of this book fast because it's fairly easy to do, or seems fairly easy to do at times. Times it'll get tough, but I'm trying to go over this fast. So we go 12 and 7. Well, you would go 12 is greater than 7, or 7 is less than 12. That's all that means. And that is important. Like I said, I skip over a lot of this. This says graph 4 on the number line. So we got 4 right here. It had it graphed, but I graphed it a little bit darker so people could see it. Now this says graph 9 on the number line. So you go over to 9 and you put a dot above that. So again, it says on the number line, what number is 4 units to the left of 11? So you find 11 and you count back 4 units because it wants to know to the left, which is exactly what subtraction is. So the number 4 or 11 minus 4 is 7. Okay, on this part, it asks for us to put the correct symbol in. Now, I did do all of these. So, your solution, 47, is greater than 19, or 26 is greater than 0. So, write the given numbers in order from smallest to largest. So, we just pick out, well, 0 is going to be the smallest. Then we search through them. 5 is the next, and so on. And that is important. Okay? Let's go over to this is how you do written. It's place value, so you have the ones, the tens, and the hundreds. So ones, tens, and hundreds. Now this is how you write them. You write them set to 100, 7 tens, or 773. Now you're not always going to have to write tens unless it's 10 on its own, because you're not going to have to write two tens because you write 20. But that is the idea behind that. Now we go over to the next one above hundreds, and we go to thousands. Then we go 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions, and trillions, which you have the trillions, 10 trillions, and 100 trillions. So far, we're not $100 trillion into debt, but I don't know, maybe this video stays around long enough, we will be. But, so when a number is written in standard form, each group of digits separated by a comma is called a period. Now, I'd never heard them called a period. I might have when I was in college. It wasn't something that stuck with me. So the number 5, and then you have this comma here. That separates it. So I believe that would be 5 billion. Then we have 316, and then we would have a comma here, which would stand for millions. Then we have 709 thousands, 842. Now, you each time you see a comma, that is going to mean you are going to say a place value, which is something I really hadn't studied. I knew, but I hadn't directly been told it. So, or if I had, I don't remember it. So, 709,000, because you have that right there. And of course, you start out with the hundreds, thousands, millions, and billions. So, try to remember that. That is important. So, next, um, we have to read the number. So it's 5,316,709,842. And this is how you would write that out. Now, a lot of people, I do know, I think my mom always used the um, the hyphen when she was separating these, but I don't usually on a check. I just write down 42. But just to let you know, there should be a hyphen there. And I do remember that from school. I just never use it because, you know what, people understand it without too. So, 6,051,874 is written. Now you would write it like this. You would write it 6. Then you have the million. Then you have the 51,874. It's just like it is there. Now, this next one, it wants us to do expanded form. I see some good to expanded form. We have 37,286. We're not going to spend a lot of time on expanded form. It's important, but if you use a calculator and to write stuff down, it's good to know, but it's not going to be used a whole lot. So we have 30,000. That's because right here we have the 3 in the 10,000 spots. Then we go over here and we have 7,000. Well, that's because we have the 7 here and the thousands here, or these would be zeros and it would be 7,000. Then we go 200. Well, that's because there's a 2 right there, so that goes 200 plus 80 plus 6. So expanded form is just expanding it out so that you're taking account for each place value of each number. So let's go ones, tens, hundreds, thousands, 10,000s. Again, it's still going over these numbers. So you have the 10,000s, you have 30, so you have 3 10,000s. Over here you have 7 in the thousands. Then you have 2 in the hundreds, 200, and 8 in the tens, plus 6 in the ones. That is very, very important that you do learn place value, because that is going to be how you read numbers. Next, we have write 82,500 or 82,593,071 in words. So it's got that written out into words. If you need to write write it out into words a whole bunch of times, go ahead. Okay? This is very important, particularly for writing a check, which not a lot of people do anymore, but I still see people once in a while walking into Winco out of all stores and paying with a check. Winco doesn't allow you to use a credit card usually. They just want you to use debit, which is kind of writing a check, I guess. But okay, so objective C is to round a whole number by a given place value. Rounding, I don't see the need for it as much anymore because everybody's got a calculator on them. And you can figure numbers out to exact with a calculator very easily, just as fast as you could enter 00000. You could you could write in the exact number. But like this, let's go 48 rounded to the nearest 10 is 50. So you take the 4 because you're rounding to the nearest 10, and this is the tens column. So you look to the right of it, and if the number to the right is 5 or above, it rounds up. I actually made an abacus, which was really nice for rounding. It had 9 numbers on it. So basically, if you go from 5 up to 9, you're going to have more numbers. If you reach 5, if you slide over 4 beads, there's going to be more on the other side because there's going to be 5. But you move the 1 bead over, and then this side becomes more, so you round up. I don't know if that quite made sense to you, but it works with the abacus because all you care about are 9 numbers when it comes to rounding. Because if you land on a 10, well, you don't have to round. So 9 numbers is what it counts to. So you say you had 4 numbers, and then you had 1, 2, 3, 4, 5 over here. Well, you have more on this side. Well, let's delete one of these and put it over here. Well, now you have 5 more on this side than on this side. So you would round up. So that's the basis behind rounding, is which side is going to have more. And I know they say 1 to 10, but 10 doesn't count and 0 doesn't count because you don't round when it's at 10 or a 0. So that is my little bleep on rounding. So this part, it still wants you to round. So you look at the 6, because that's where you're going to be rounding, is the 6. That's your given place value. So that would be 6,000. Then you look to the number to the right, and it's 7. Well, 7 is greater than 5, so you round up. If that had been a 4, you would have rounded down. So this number, because you're rounding up, becomes a 7. So it ends up being 47,000 is the rounded number, like it has right here. So a given place value, again, this is still rounding. Rounding is done the same way no matter how many you have. You just find the place value that it wants. Right here it says nearest hundreds. So we look here at our hundreds. I already did this with the boys, but it's 9. So you look over and you have 9 is in the hundreds, which is where it wants to round. Then 8 is in is to the right. 8 is greater than 5, so it means you have to go up on the 9. Well, it would be 10. Well, that 10 would just mean that 7 would go up. So it would be 80. So it would be 8. No, it would be 8,000. So, okay, next we go on to objective D. I'm trying to cover all of lesson 1.1 in these lessons, but number objective D is to solve application problems and use statistical graphics. So, graphs are displays that provide a pictorial representation of data. So, right here you have, I don't know, I don't even see Jeff Bezos or Elon Musk on here, just Gates as the richest man. Obviously, this isn't a brand new study, but if you look up here, this says their net worth in tens of billions. So each of these is $10 billion. We have 10, 20, 30, 40, 50, $60 billion that Gates would have. And then there would be 50 billion that Warren Buffett would have. Larry Ellison would have 40 billion. Christy Walton, I'm assuming that's one of Sam's relatives, but I don't know that, has 30 billion. Sheldon Adelson has 10 billion, so you would have 20 billion. And this is just a way to look at it, and you can tell by looking at this, Gates is the richest. Now, these have all been rounded because Gates probably doesn't just have that many billions. He's got some change in there too. Okay, so next we have my favorite type of chart, a um, pie chart, basically. This calls it a circle graph. So $40,550 is what the average household has. I believe it says after taxes, after tax income. So this tells about what people spend the most money on. Well, you can look at the biggest section, and you know that's going to be the most. 12,827 on housing. Yes, housing is outrageous and it's getting worse. So most of your income goes to housing. A big part of your income goes to transportation. There's a lot of people, in order to have a house that they can afford to live in, have to live away from their job. So they have to transport to get there. Food's another huge one. Other, I don't know what other would be. Insurance, pensions. That takes a lot out of your paycheck. Clothing, health care, and entertainment. Those are fairly small ones. And the problem I have is you look at those, and those are the ones you can cut them out. They are the easiest to cut are clothing and entertainment, and they're actually they're the smallest anyways. So, okay. Again, we're still dealing with um, a pie chart here. This is interesting. You have 300 people who were asked to name their favorite sport. So, football, of course, had the most. Then basketball. Then baseball. I don't know if that would be true. Baseball might be more than basketball. I'm pretty sure football still takes the lead. Tennis, hockey, and golf. Now, if somebody were to ask you, well, which is the smallest? You can just look up here and boom, you can see golf is the smallest one. I do not know how accurate that would be, but it's still fun to go over. So, according to figure 1.7, which sport was named by the least number of people? Now, of course, this wants us to write down a strategy. I don't usually worry about writing it down a strategy because I can usually strategize it in my head. I know what I'm going to be looking for. But in this it in this book, which is a fundamental book for college to get you up to um, uh, college level, it wants you to strategize. I don't know if they would really make you do that in a class, but it would just be you need to find out what your strategy would be to find the name by the least number of people, find the smallest number given in the circle graph. Well, you can also just look at the smallest chunk of pizza out of the pizza pie, as my teachers in school used to call it. Your solution. The smallest number given in the graph is 20. Um, the sport named by the least number of people was golf. So if you have to, like when I was doing it with the kids, we just wrote down football. We didn't write down all of this. Um, but if your teacher wants you to explain it, you can explain it. I just want you guys to be familiar with a pie chart. So, now this one here wants an inequality. The distance between St. Louis, Missouri and Portland, Oregon is 2,057 miles. The distance between St. Louis, Missouri and Seattle, Washington is 2,135 miles. Which distance is greater? What it wants you to do by that is to do an inequality. So you would have to compare the numbers of the distance, 2,057 and 21,000 or 2,135. And you would put them into an inequality. And from that, you would find out which distance is longer or greater. And on here, this is another, I think you'd call it a bar graph. I actually don't, yeah, it says the bar graph. So it's showing you numbers, and it's got the numbers written above because sometimes they're hard to tell. Like if you were to go New York or Ohio, they both have 239,000. Both have a zero, or no, that one's got 951, and this one's got 10. Well, 951 is greater than 10, so New York would have more, which is bowlers. Okay, so um, this is how you would do that. And here's some more examples. I'm going to go over this fast. I will put um, some worksheets on my website over how to do these. Now, it gives us here a bunch of exercises. I did these along with the boys I tutor. So um, I just wanted to go over this really fast. What I am out to do. I am not a math wizard myself. I struggled a lot in math in school. Um, I do teach in a resource class math, and I want to catch every kid up, every person up in math. I don't want you to have to go to college and take all of this. And this would be a very early fundamental college in book and college that you would have to take. And I want to try to prevent that from happening. I want to show you guys this so that when you go to college and take that placement test, you can um, ace it. Here's some on the, or that you can score high enough that, okay, maybe you have to take a couple of fundamental classes. I had to take a year of fundamental math classes. I did not start at the bottom though. So I had to take math 60, math 65, and I think it was math 95 at a community college before I could get into college level classes. So, next we will be doing chapter 1.2. 1.2 is just addition and subtraction of whole numbers. Here, we're going to go over this really fast because, like I said, I like a calculator. I do not see as much of a purpose of some of this stuff, but you still have to have the knowledge. Because what if, and inequalities is important, but what if you're taking a placement test and it says, um, what is a whole number that's not a natural number? Well, that was B0 as we studied up at the top. So, anyways, if you guys have any questions, put it in the comment section. I will try to um, get as much written as I can, or get as much done as I can. I'm losing track of what I'm doing because my computer is messing up on me. Um, so, anyways, thank you guys for watching. Subscribe if you want to get into some more of this. Like I said, I am just giving a foundation for math so that you guys can do good. So, I will talk to you later.